module, we are going to study the rules for making ray diagram of convex mirror and also the ray diagram of convex mirror. Let's start with the 4 rules. The first rule, students, it says a ray of light which is parallel to the principal axis of a convex mirror appears to diverge from the focus after reflection from the mirror. Let's see here, if this is the base diagram, then it says if a ray of light is parallel to the principal axis, then after reflection the ray appears to diverge from the focus. So it appears to diverge from the focus. Coming to the second rule. The second rule, it says a ray directed in the direction of the center of curvature of a convex mirror is reflected back along the same path. So if there is a ray which is directed towards center of curvature, then it gets reflected back along the same path. Coming to the third rule. The third rule, it says a ray which is directed towards the principal focus of a convex mirror becomes parallel to the principal axis after reflection. So if the incident ray is directed towards the principal focus, then after reflection, the reflected ray will become parallel to the principal axis. Coming to the fourth rule. The fourth rule, it says a ray of light which is incident at the pole of a convex mirror is reflected back, making the same angle with the principal axis. So basically, if incident ray makes an angle with the pole, that is 30 degree, then the reflected ray will also make the same angle with the pole. That is again 30 degrees. So they are the 4 rules for making ray diagram of convex mirror. Let's move further with the next ray diagram of convex mirror. Students, you have already studied the first 6 ray diagram of concave mirror. So this is the 7th diagram for convex mirror. Basically, rest of the things, if you see, it remains same. First, you make the base of the ray diagram. Your base diagram is ready. After making the base, instead of placing a concave mirror, now you will place convex mirror. Now students, the next thing, it says object is at infinity. When I say object is at infinity, infinity means very, very far away. So I place the object here and object is named as AB. After this, you use rule, right? That will use the first rule. The first rule, you all know, if the incident ray is parallel, then the reflected ray appears to come from the focus. So here, it appears that the rays are coming from the focus. It means all the rays are meeting behind the mirror at focus. So based on that, you have to write 2 things, that is position of image and nature of image. Position of image, if you see, where is the image? It is at focus, right? So we say at F. Next comes nature of image. Now in nature, students, it is behind the mirror. Whenever it is behind the mirror, we say it is a virtual image. So why virtual? Because as the rays appear to meet behind the mirror. Next, students, virtual images are always erect, right? So here at focus, the image that you will get is erect image. And finally, the image size will be very, very small because it is meeting at a single point. So we say the image is highly diminished. Why highly diminished, students? As it is a point size image. Let's move further to the last ray diagram, where the object is placed between infinity and pole of a convex mirror. First thing, you make the base of the ray diagram, then we place the object. Now the object is placed between infinity and pole, right? That is behind pole basically. Now you use the first rule. If the incident ray is parallel, then the reflected ray, it appears to come from the focus, right? Second rule, again, if a ray is incident towards center of curvature, then the reflected ray, again, it comes from center of curvature. After applying the 2 rules, where are the 2 rays meeting? They are meeting between pole and focus, right? So I'll get an image there between pole and focus. And the image that you can see is a erect image, A dash, B dash. Let's write the position of the image now. The position of the image will be between pole and focus. The next thing is nature of image. In nature, students, because it is behind the mirror, obviously it is a virtual image. Virtual images are always erect, right? And finally, the size, if you see, students, here the object is bigger in size and the image is smaller in size. So you will say it is a diminished image. So these are the ray diagram for convex mirror.